Hello, this is Geometry, Topic 2-3, over segments and distance. So first let's go over vocabulary term. When we're talking about a line segment, we're talking about the part of a line bound by two endpoints and everything in between. So that's a sketch of our line segment. I'm going to go ahead and copy that over here. Now, the name of the segment would be AB, and we put a bar on top. This we read as line segment AB. However, if I want to know the length of segment AB, I would simply write AB and I would not put a bar over it. Putting a bar over this line segment says that I'm naming it. Leaving the bar off means that I'm talking about the distance from A to B, or the length of that line segment. So, if I want to measure the length of a segment, I can use a number line to count the distance between the two endpoints. This is the simplest way to do it. And the idea is that we want to find the distance between -2 and 6 on a number line. So I'll go ahead and draw my number line. I put down -2, and I'm going to keep on going until I hit 6. -1, 0, 1, 2, 3, 4, 5, and 6. And this is a number line. It actually goes on forever. And I've got one endpoint that falls on -2, and another endpoint that falls at a +6. And I want to know my distance. Well, this is simply put 1, 2, 3, 4, 5, 6, 7, 8. And so it is just a matter of 8 units. It's 8 units to go from -2 to +6. Another way you could do this is you could just say -2 minus 6. And we want to find the absolute value of that. And we get 8. Because -2 minus 6 is -8. And the absolute value of that is 8. So I can do this with a number line. I can do this with subtraction. Let's go ahead and find the lengths of these. So PQ, again, I know this is a length because there's no bar over it. Well, PQ, 1, 2, there's 3 half steps. So that would be 3/2, or 1.5. Mathematically, I would say -2 minus -3.5. And that would also give me a 1.5. Now if I want to find QR, well, I'm moving by 1, 2, 3, 4.5. Or I could simply say 2.5 minus -2. And that's going to give me 4.5. And now PR, which moves 1, 2, 3, 4, 5, 6. I'm just moving from half step to half step, so it moves a total of 6. Or I could say 2.5 minus a -3.5. And that would also give me 6. So all those methods work. This doing subtracting to find the length is better if you have large numbers, but if they fit on a simple number line, you can just count from one to the other. Now this only works when we're talking about one dimension, and a lot of times we need to find the distance of something that is two-dimensional, and to do that we have what's called the distance formula. But before I even talk about the distance formula, let's talk about where the distance formula comes from And to do that, I'm going to look at example number 4. So we're going to skip the top of this page, jump down to example number 4, and then we'll work our way back up. Well, I want to find the distance between A and B. And one way I could do that without having my distance formula is I could go ahead and draw a triangle, and here I have a right triangle, and with this I can use Pythagorean's theorem. Okay? Now, Pythagorean's theorem is something that you talked about back in 8th grade. If you have a right triangle, then a squared plus b squared equals c squared, where c is your hypotenuse. So I'm going to call this A. Actually, I'm going to go ahead and just use lowercase. A squared plus b squared equals c squared. And so we'll call the side opposite A, and the side opposite B, B. And let's find out the lengths. Well, A is 1, 2, 3, 4, 5, 6, 7, 8 units long. B is just 2 units long. We want to figure out what this is. Well, 8 squared is 64. Plus 2 squared is 4. Gives me 68. Well, this equals c squared. And so this is 68 equals c squared. To find out what c is, I need to take the square root. And the square root of 68 is roughly 8.25, because the 6 rounds that 4 up to a 5. Now, this was Pythagorean's theorem, and it works because I have a grid and I can draw a right triangle. However, it doesn't help me for problems like example number 3, where I don't have that grid. So let's go ahead and see if we can solve number 4 another way. Well, A was this far, and so I can take this y value of -3 and subtract my b value, 1, 2, 3, 4, 5. Okay. And that will give me a distance if I take the absolute value. So this is y1 minus y2. Well, to get b, I did the same thing. I took my x value of 2, subtracted my x value of 1, 2, 3, 4. I'll take the absolute value of that, and I call that x1 minus x2. Now, if you notice, I square these. So I'm going to go ahead and just say squared, and I add them, and that gave me c squared, which was my distance squared. Which I'm just going to shorten down to d squared. Well, I don't want d squared, I want to know what d is. Well, the opposite of that, if I take x1 minus x2, and I square it, plus y1 minus y2, and I square it, if I take the square root, I get that d equals the square root of x1 minus x2 plus y1 minus y2, and both of these are squared on the inside. And so this actually is our distance formula. Now you may point out, Mr. Nichols, you put absolute values here, you didn't put them there. Well, that's because anytime you square something, you make it positive. So I didn't need to do that. Okay? Again, this was A, that was B. Alright, so this is my distance formula. You may see them put x2 minus x1 and y2 minus y1. It really doesn't matter which order you put that in. It's helpful that if you start off with 1 in the front, you put 1 in the front. Or if you start off with 2 in the front, you put 2 in the front. But ultimately, for the distance formula, it doesn't matter. You're just subtracting x coordinates, subtracting y coordinates, squaring those differences, adding them together, and then taking a final square root. So let's go ahead and just rewrite this formula up top. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. And so that's our distance formula. And now we're going to use this to solve example number 3. And so I'm just going to go ahead and rewrite this. We're going to call this x1, y1, x2, y2. And so now I do 2 minus negative 2 squared plus negative 1 minus negative 3 squared. x1, x2, y1, y2. And now we're going to go ahead and work this. Negative 2 minus, 2 minus a negative 2 is really 2 plus 2, which is 4 squared. Plus negative 1 minus a negative 3 is really negative 1 plus 3, which is 2 squared. And then 16 plus 4, that equals the square root of 20, which is approximately 4.47. Now, if you would like, you could put this whole thing into the calculator. Make sure you do it correctly, though, so that you don't mess up with parentheses, get negative signs wrong, and that your square root covers everything. So that's finding distance when we're given points. But now, let's go ahead and take a look at something else. Now over here it says to examine PQ, QR, and PR in example number 2. Well, PQ was 1.5. QR was 4.5. And PR was 6. And 1.5 plus 4.5 equals 6. So that means that PQ, which was 1.5, plus QR, which was 4.5, equals PR, which was 6. And that gives us what we call the segment addition postulate. It's basically, if I have a straight line, and Q is between P and R, then PQ plus QR equals PR. Or part plus part equals whole. Let's go ahead and do this for example number 5. I have a line. B is between A and C. AB is 4, BC is 5, and we want to know what AC is. Well, that's quite simple. We just do 4 plus 5 equals 9. Very simple. Let's go ahead and do this again for example number 6. I have a line. AB equals x. So we've got A, B, and C. AB is x long, BC is x plus 6 long, and AC is 24. And we need to find all of this. Well, I know that this line segment plus that line segment equals the total line segment. So x plus 6 equals 24. Go ahead and start simplifying. That gives me 2x plus 6 equals 24. Subtract 6 from both sides. Two x equals 18. Divide by 2 and we get that x equals 9. Well, AB is x, so that means that this would be 9. BC is x plus 6, and 9 plus 6 equals 15. And just to double check, 15 plus 9 equals 24. And there we go. We have one last example to work out. Find LM if L is between N and M. So N, L, M. NL is 6x minus 5. LM is 2x plus 3. And NM, the whole thing, is 3x plus 13. Well, again, this part plus this part equals the whole. So, 6x minus 5 plus 2x plus 3 equals 3x plus 13. If we combine like terms, 8x minus 2 equals 3x plus 13. X is to one side. 5x minus 2 equals 13. Constants to the other. 5x equals 15. Divide by 5 and x equals 3. Well, it's not asking us for x, it's asking us for LM. So 2 times 3 plus 3 is 6 plus 3 makes 9. And so that is example number 7. So we've talked about how to find distance in the one-dimensionally, find distance two-dimensionally, and find distance using the segment addition postulate. Good luck on your assignment. Have a good day.